In this video, we are going to talk about the equation of a circle. So there are two common forms for the equation of a circle. First, we have what's called radius center form. And I'm going to try to show where this comes from with a picture. So here I have a circle where I have the center at this point h comma k. I have the radius, which I'm labeling as r. And then I have this other point that's on the circle, which I'm calling x comma y. So the definition of a circle that has center h comma k and radius r is, well, it consists of all the points x comma y like this, whose distance, so I'm going to fill in the blank, whose distance from that center point h comma k, well, that distance always stays the same. It's always just r. So in other words, the distance between x comma y and h comma k, that distance should just equal r. Okay, so now, well, in the last video, we saw a formula for the distance between 2 points. Let's set up that formula. So that formula involves a big old square root, and then inside it, I'm going to subtract my two x values and then square that. So x minus h, and then square that, and then add to that. Now to do the same thing with the y values. So subtract them and then square that quantity. Y minus k getting squared. And then, well, that's equal to the number I have here. That's equal to r. Okay, so that gives me, well, this distance equals r. And now to simplify this equation, I can get rid of the square root if I square both sides. So now I'll take this, let me square both sides. So square both sides, and if I do that, it'll get rid of the square root on the left. And I will get parentheses x minus h getting squared plus parentheses y minus k, that quantity getting squared, equals, on the right, I'm going to get r squared. And I'm going to highlight that, and hopefully that should look somewhat familiar, because you've probably seen this in algebra class before. This is the equation of a circle in what's called radius center form. Because when it's written in this way, I can identify the center. So the center at the very beginning we said was h comma k. So h comma k. Another way I kind of think about that directly from this equation is the x coordinate at the center is what I would plug in for x to make this parentheses become 0. And I would plug in h for the x. And then the y coordinate of the center is what do I plug in for the y to make this parentheses be 0. And that would be whatever k is. And then the radius is, well, the radius is r. So whatever number you have on this right-hand side, you got to square root that to get the radius. Okay, so sometimes we'll see the equation of a circle written in this way. We can also FOIL these out, like x minus h squared means x minus h times x minus h. And then same thing with y minus k getting squared. And if you do that, you can write the circle in what's called standard form. Standard form will look something like this. You'll have an x squared term, a y squared term, and when you FOIL these, you'll have something times x, something times y, where the a and the b are reals. And then, collecting all the constants, you might have some extra constant, some number, which I'm calling c, and then that's going to be equal to 0. Okay, so let's do an example. So if the center of a circle is this point, negative 6 comma 9, and the radius is 4, write the equation in standard form. Well, if I'm given the center and the radius, I can definitely plug them into my radius center form. So let's do that first. So the radius center form says, okay, do x minus the x coordinate of the center. So it should be x minus negative 6. And then square that quantity. Plus y minus the y coordinate of the center. So y minus 9. And then that should get squared. And that on the other side, that should equal the radius squared. So this should equal 4 squared. Okay. And well, now to get it in standard form, we need to distribute these out. So my double negative becomes a positive. So like x plus 6 squared, well, that means it's like x plus 6 times another x plus 6. And then y minus 9 times another y minus 9. I'm going to leave it to you to FOIL these out. But if you do that, the first one becomes x squared plus 12x plus 36. And then I'll get plus. If you FOILed out the y terms, you'll get y squared minus 18y plus 81 equals, and then 4 squared becomes 16. And now to put it in my standard form, well, we write the x squared and the y squared first. So x squared plus y squared. Then you write the terms with x and y. So plus 12x minus 18y. And then you collect all the terms that don't have any variables together. So that's the 36, that's the 81, and it's the 16. So if I subtract 16 over 36 minus 16 is 20. And if I add 20 to 81, well, I'll get 101. So plus 101, and that equals 0. And that's my circle equation in standard form. So usually it's a lot more helpful to us if we have the equation in this radius center form, because I can just read off the center and the radius very quickly when it's in this form. But if I was just given something in the standard form, it's kind of hard to identify the center and the radius super quickly. So how do we do that? Let's do an example. Let's say I want to find the center and the radius of this circle, which is right now in standard form. And then we'll also find the intercepts and sketch the graph of the circle. To do this, we have to do what's called completing the square. And what this does is it'll turn quadratics into perfect squares. Perfect squares meaning, it'll factor as like x, and then maybe there's a number like minus something or plus something. But then the whole thing ends up getting just squared. Rather than like, x minus 3 and then x with like a different number. I just want it to be a perfect square, like something times itself. Okay, so how do we do this? How do we complete the square? Well, the first step is you divide the coefficient of the x term. So here's just the x term, not x squared, just the x term. Or if there's a y term, which in my problem there is, it's this one. You divide those coefficients by 2, and then you square them. So if I do that for the x term, let's take the coefficient, which is 6. So the coefficient's the thing without the actual variable. Divide it by 2. And if you do that, you get 3. And now I have to square that number. Okay, so I'm about to start a new step. Squaring is a new step. So I'm going to draw an arrow to indicate a new step. And then I'll write 3 getting squared, which is 9. Okay. And if I do the same thing now for the coefficient of y, well, the coefficient of y is negative 16. So let's take that negative 16, divide it by 2, which gives me negative 8. Now I'm about to start a new step. So I'll indicate that with an arrow. And then I'm going to write my whole negative 8 getting squared. I need a parentheses around it to indicate the negative is also part of what's getting squared. So that's 64. Okay, so before we keep going with this, I want to point out a really common error people make in how they write this. So don't write this, like for example, this first one. Don't write it as, we first did 6 divided by 2, which was 3. And then just put the squared on this and say, okay, well, 3 squared is 9. So why? What's wrong about this? Well, we've kind of done two things in one at this step. Like if I look at this, 6 divided by 2, that's 3. But I'm saying that 3 is equal to 3 squared? But that's not true. This is saying 3 is equal to 9. So this equal sign is not correct anymore. This is not true. So when we want to perform two different operations like that, like dividing by 2 first, and then squaring it second, I can't connect them with an equal sign anymore. I have to use a different symbol, this arrow, to indicate it's a new step, completely separate step. Okay, so what do we do with these perfect squares? Well, we add that term to both sides of our equation. So I'm going to move all the x terms first. So x squared plus 6x. We'll put those first. And then the term I got from the x coefficient when I went through the process was 9. So I'm going to add 9 to the end of this. I'm also going to add 9 to the other side. So this will be equal to, I have 0 on the other side. And I'm going to add 9 to the end. Because whatever I do to one side, I also have to do to the other. Let's do the same thing for the y terms. Now I'll do my y terms plus y squared. We have minus 16y. And then the perfect square I got from the y's was 64. So let me add 64 here. And if I do that to this side, I also got to do it to the other side. So add 64. And now, if I did this right, well, I should have two quadratics that factor perfectly as perfect squares. So these ones with the x terms and these ones with the y terms should factor as perfect squares. Oh, and I'm realizing I think I forgot one term. What did I forget? Oh yeah, I forgot that I had a 48 here on the left. So let's fill in that missing 48. I was wondering where that came from. So let me give myself some room. And let's fill in that missing 48. So plus 48 should still be there, right? Okay. Okay, so well, let's factor these. So these first three terms, well, that factors as x plus 3 times x plus 3, right? I'm looking for two numbers that multiply to 9 and add to 6. So that would just be x plus 3 times x plus 3. Or I could write that more simply as x plus 3 getting squared. Okay, I want to have you do a quick pause now for 1 minute to see, can you factor these y terms? The y, yeah. So pause it in 3, 2, 1. Try to factor these three terms. So I'm looking for two numbers that multiply to positive 64 and add to negative 16. Okay, so hopefully you tried that. Those also factor as a perfect square. It'll end up being y and then minus 8 times y minus 8. And that's just y minus 8, that quantity squared. Okay, and then, well, I can simplify all these constants. If I subtract the 48 over, I'll end up just getting 25 on the right. Oh, so that's really nice. So what I have now is, well, I got a perfect square with the x's, perfect square with the y's, and then some number on the other side. This is now in my radius center form. So I'm ready to write down the center and the radius. Okay, so the center. Well, the x coordinate of the center is, what do I plug in for the x? To make this parentheses thing be 0. And I would plug in negative 3. The y coordinate is, what do I plug in for the y? To make this one be 0. And that would be 8. So that's my center. And then for the radius, remember the number I get on this right-hand side, that's the radius squared. So the radius is the square root of that. It's the square root of 25, which is just going to be 5. Don't need a plus or minus because the radius is a length that should be non-negative. Okay, so I got the center, I'll box that, got the radius, and we got that. Now I want to find the intercepts. So let's find the intercepts. So if I'm trying to figure out, imagine I have a graph. Imagine I have a graph, I draw some axes, and now I want to figure out the x-intercepts. So if I have some graph, and now I want to figure out, well, where does it cross the x-axis? One thing I notice is, wherever that x-intercept is, there's some x-coordinate, and the y-coordinate is going to be 0. So if I want to find this x-intercept, the y value's got to be 0. So we're going to set our y equal to 0. Okay, so when we do this, I could either plug that into my completed the square version, this thing, or I could plug it into this original, but it turns out that the algebra is going to be easier if I plug it into the completed the square version. Okay, so if I plug it into that, we end up getting, well, x plus 3, that quantity squared plus, and then it's going to be 0 minus 8. 0 minus 8, that quantity getting squared equals 25. All right, and well, if I simplify this, I get negative 8, that getting squared, that's 64. So I can subtract that over to the other side because I'm going to try to isolate this x. So if I do that, I'll get x plus 3, that whole thing squared. And 25 minus 64, that's negative 39. Ooh, and now I can tell actually, without doing any more work, that this definitely is going to have no solution. It's definitely going to have no solution because no solution since if I have some big old stuff getting squared like this, well, something squared can never end up being negative. Something squared is always non-negative. So what does that mean? I was trying to find my x-intercepts, but I ended up with an equation with no solution. That means there are no x-intercepts. that means there are no x-intercepts. In fact, when we go to graph that in a little bit, we'll visually see that it never touches the x-axis. So what I want to leave for you to try now is we'll try to find the y-intercepts. So to find the y-intercepts, my y-intercepts, at the y-intercept, now it's the x that's going to be 0. So I'm going to be setting the x coordinate equal to 0. So I'm going to set my x equal to 0. So I'm going to leave that for you as a practice problem to try. We'll talk about how to work that in class. And then once we do that, then we'll bring it together and we'll graph the whole thing.